Imagine for a second, right, that you are running a business and you decide to hire this team of like elite Harvard-educated PhDs.
Okay, sounds expensive.
Oh, incredibly. You pay them thousands of dollars a day, you put them in this state-of-the-art corner office, and then you give them their actual daily assignment, which is sorting your junk mail.
I mean, you'd be fired instantly. It's just completely absurd.
Right. It is absurd. Yet, when we look at how the tech world is deploying artificial intelligence right now, we are kind of doing exactly that, just millions of times a day.
Yeah, it's a huge issue. We have this massive asymmetry in how we talk about AI right now. Like, everyone is completely obsessed with the raw size of the engine.
Parameter thresholds, reasoning benchmarks, all that.
Exactly. We argue over whether the newest frontier model is, technically a few percentage points smarter than the last one. It's a totally consuming focus for the whole industry.
But the danger there is, well, if you're staring exclusively at the engine block, you completely forget to ask where you're actually driving the vehicle.
Precisely. The obsession with raw capability just crowds out the practical reality of deployment.
Which crowds out a question that is honestly way more urgent for anyone like you listening to this, who is actually trying to use these tools to get things done.
Right.
And that question is, are we using what we already have wisely? So, welcome to the deep dive. Today, our mission is to explore a truly fascinating opinion paper. This is dated February 1st, 2026, and it's titled Intelligence Migrates Outward.
Such a great title.
It really is.
Yeah.
It was written by Momin Ghazwani, who is the chief scientist at Settler Aplanda. And we should probably note right up front, this was published as an independent analytical inquiry.
Right, so it's his own perspective. It's not an official company stance or a press release.
Exactly.
Which is incredibly valuable, honestly, because it allows for a much more candid, kind of unvarnished assessment of where the industry actually stands. It's completely stripped of the corporate marketing spin.
Yeah, he isn't trying to sell you a new model.
No, he's trying to diagnose a systemic failure and how we use them.
Okay, let's unpack this. Ghazwani identifies what he calls a massive gap. I mean, a canyon, really, between what current AI systems are theoretically capable of doing and what organizations are actually extracting from them in practice.
Yeah. And to understand why the locus of value in AI is shifting, we first really have to look at the glaring inefficiencies staring us right in the face.
The junk mail problem.
Exactly. Ghazwani points out that practitioner communities, meaning, the developers and engineers, actually building applications with these tools every single day, they have this recurring core complaint.
Which is?
They are routinely deploying models of extraordinary, mind-bending complexity to accomplish incredibly modest, mundane tasks.
Okay, let's ground this a bit. What does that actually look like under the hood?
Well, the paper highlights a few perfect examples. Imagine invoking a 175 billion parameter model just to summarize a standard 2-page internal document.
Oh, wow.
Or taking a system that was painstakingly trained to perform sophisticated multi-step logical reasoning and assigning it the job of simply reformatting a column of dates in a spreadsheet.
Just changing the date format.
Right. And when you do that, you are incurring massive inference costs.
Let's define that really quickly just so everyone's on the same page. Inference cost is basically the actual price of running the model.
Right. Exactly. Every time a model generates a response, which is an inference, it requires compute power. It lights up thousands of GPUs, it consumes massive amounts of electricity, and it takes time, which we call latency.
Right.
So when you use a massive model for a simple task, the computational costs measured in dollars, energy, and seconds, they're wildly disproportionate to the actual cognitive demand of the task itself.
It sounds like renting a stadium-sized supercomputer just to balance a checkbook.
Yes.
Like, sure, it'll get the math right, but the sheer waste of resources is comical. But hold on, I want to push back on this premise just a little.
Okay, go for it.
If the problem is simply that we are using a sledgehammer to swat a fly, isn't the fix entirely straightforward? Like, don't practitioners just need to be a little smarter about picking the right model size?
You would think so, right?
Yeah, just use a tiny, cheap model for the data formatting and save the giant, expensive model for writing a complex legal brief. Problem solved.
That is the exact assumption most people jump to. They view this merely as a matching problem, like it's just a glitch in the deployment layer.
But Ghazwani disagrees.
Totally. He argues that while better matching is necessary, it is absolutely not sufficient. The deeper issue here isn't just about picking the right tool off the shelf. The issue is structural.
Structural in what way? Because if I match the tool to the task, haven't I solved the inefficiency?
Not if the task itself is poorly conceived.
Oh, interesting.
Right, it's about how a task is defined in the first place. How is a massive project decomposed into smaller, solvable steps? And how is that one specific task situated within a larger, automated workflow?
I see.
Taking a well-scoped task and giving it to the right model isn't just a cost-saving measure. Ghazouani says it is an act of architectural reasoning. It requires a decision about where deep intelligence is genuinely needed, and just as importantly, where it's completely unnecessary.
But wait, compute power is getting cheaper every single day.
Oh.
I mean, look at the historical curves. The cost of processing always drops exponentially.
True.
So eventually running that stadium-sized supercomputer will cost, a fraction of a cent. So won't this whole inefficiency problem just naturally solve itself over time?
That perspective right there is exactly what Ghazouani calls the scaling correction view.
Okay.
It's the belief that this is all just a temporary economic glitch, but he rejects it entirely. And the reason comes down to basic math regarding task volume.
The volume of tasks. Okay, walk me through the math on that.
Sure. Think of it this way. Yes, the cost of a single inference is falling dramatically, but the sheer volume of tasks we are automating and throwing at AI is exploding at a much, much faster rate.
Oh, I see where this is going.
Right. So if the cost to run a specific AI task drops by a factor of 10, you might think, hey, I'm saving money. But if, because it's cheaper, your organization suddenly runs 100 times more of those tasks,
then your aggregate inefficiency hasn't shrunk at all.
Exactly. It has actually grown massively. You are bleeding resources at scale because you are executing millions of poorly structured tasks.
All right, so we can't just wait for compute to get cheaper.
Right.
But what if we attack it with better infrastructure?
What do you mean?
Like, if the problem is that humans are bad at routing tasks to the right models, why not just build software that sits in front of the models? It looks at a user's prompt, and it automatically dispatches it to the cheapest model that can handle it. Doesn't that solve the structural issue?
So you're describing what the paper calls the tooling gap view.
The tooling gap view.
Yeah. It treats the inefficiency purely as an engineering problem, something that can be solved with automated routers and adaptive dispatch systems.
Right.
But again, Ghazouani says this treats the symptom, not the underlying disease.
Why, though? I mean, if the system automatically routes the easy math to the cheap model, isn't the waste gone?
Because of the classic paradigm, garbage in, garbage out.
Yeah.
Even if you have the most perfectly engineered routing system in the world, if you feed it a massive, tangled, poorly scoped problem, the router doesn't know how to fix the problem itself.
It just passes the mess along to a model.
Exactly. Automated routing doesn't replace the need for someone or something to architect the workflow intelligently.
Which brings us to the core of his argument. If cheaper compute won't save us, and automated routers aren't enough, what is the actual